This is a short presentation depicting the format of assembly language programming. Assembly language programming is writing machine instructions in mnemonic form using an assembler to convert these mnemonics into actual processor instructions and associated data. Assembly language statements are written one per line. A machine code program thus consists of a sequence of assembly language statements. Now we explain the various elements used in assembly language code. Mnemonics. A mnemonic is an abbreviation which represents the actual instruction. Mnemonics are used because they are more meaningful than hex or binary values, reduce the chances of making an error, and are easier to remember than bit values. Opcodes and operands. The opcode field contains a mnemonic. Opcode stands for operation code, that is, a machine code instruction. The opcode may also require additional information known as operands. This additional information is separated from the opcode by using a space or a tab stop. Label. The label is used in the program as a reference for memory location, the value of a piece of data, the address of program, subroutine, code portion, etc. The label field is optional. Labels are extensively used in programs to reduce reliance upon programmers remembering where data or code is located. An advantage of using labels is that inserting or rearranging code statements do not necessitate reworking of actual machine instructions. The maximum length of labels differ between assemblers. A label, when declared, is suffixed by a colon and begins with a valid character. Comments. The comment field is optional and is used by the programmer to explain how the coded program works. Comments are preceded by a semicolon. The assembler, when generating instructions from the source file, ignores all comments. Here we explain a small fragment of multiplication program for two 8-bit numbers depicting the use of labels, opcodes, operands, and comments. In this fragment, we are using two labels, mult and skip. The mult label contains various mnemonics for different instructions which lead to the multiplication of the two numbers by repeated addition. Similarly, the skip label contains the instruction mnemonics which serves as a counter that governs the number of times repeated addition has to be performed in order to result into the product of two 8-bit numbers. Now we show a full-length program for multiplication of two 8-bit numbers in assembly language format, clearly depicting all its elements. Thank you.